Section 5.2, Solving Systems of Linear Equations by Substitution. So we've already looked at solving systems of linear equations by graphing, but we mentioned some of the shortcomings. First of all, it's not always exact, and what we have here is another method, a little more algebraic method, that will allow us to solve any system of equations, even when graphing would be difficult. The key for this is to use substitution, which means having one variable totally by itself. In this second equation, you can see that y is isolated on one side of the equal sign. It says y equals 2x plus 2. That means that for the purpose of this problem, anytime I see y, I can replace it with 2x plus 2. So I'm actually going to take this expression here, 2x plus 2, and I'm going to put it into my other equation for y. So I'm going to rewrite that equation out. 3x plus 2, I'm going to leave some space instead of a y right there, equals 11. Now instead of the y, I still want to have this equation look the same. 3x plus 2y equals 11, but I just said I can replace y with 2x plus 2. So now what I'm going to do is I'm going to distribute my 2. I'm just solving this equation out because now it's an equation in one variable. So I still have my 3x, that's plus 4x plus 4 equals 11. I'm going to combine some like terms there. That's 7x plus 4 equals 11. Subtracting 4 from each side, I get 7x equals 7, and dividing each side by 7, I get x equals 1. So I've got the first part of my answer, which is x equals 1. I'm now going to take that and plug it into my second equation from the beginning. I'm going to have y equals 2 times something plus 2, but that something is the x value that I now have, which is 1. That means y equals 2 plus 2, and 2 plus 2 is, of course, 4. And now I have my second part of my answer. So what I could do is I can now write my final answer as an ordered pair. 1, 4. I got to make sure I put the x part first. And 1, 4 is my final answer. Now in order to check that, I would take 1 and 4 and plug them in for x and y into each of my equations. 3 times 1 plus 2 times 4, that would become 3 plus 8. That is indeed 11. And if I put it 4 for y, is that the same as 2 times 1 plus 2? Yeah, because that's just 2 plus 2, which is 4. So that's how you check. This is just a system of equations that has one solution. All right, let's see if it's sometimes a little bit trickier. See what else we have to do. All right, so here we don't have any of the variables isolated completely. We're close though. So all we need to do is we need to pick which variable we want to get along. We've got 4 choices. We can get this x, this y, this x, or this y. So you want to pick one that's really convenient. If I try to get this x by itself, I'm going to have to add 3y and then divide by 5. That's way too complicated. So pick the term that has a variable that's going to be easiest to get alone. Probably just this x because there's no coefficient. That means we just have to rewrite this first or the second equation by subtracting 2y, getting x equals negative 2y, which is 0 minus 2y, which is negative 2y. Now, just like before, I'm going to take that expression, the negative 2y, and I'm going to substitute it in, but this time it's going to go in for x. It doesn't matter if we use x's or y's here. It's kind of up to us. We want to pick something that's convenient. So just to show you what that would look like, I'm going to have 5 times something minus 3y equals 13. And what's that something? Well, I know that I can replace x with negative 2y. Multiply that out. 5 times negative 2 is negative 10y. Minus 3y equals 13. Combining like terms. Dividing by the coefficient, I get y equals negative 1. And that's the start of my answer. I'm now going to take that and plug it back into this problem, this equation here. So I'm going to get x equals negative 2 times negative 1, or just x equals 2. So now that I have both parts, I put them in numerical and alphabetical order, I should say. X is 2, y is -1, and that's the answer that I need to have. So using substitution here, you can pick whichever variable you want to get by itself, but just pick wisely. Pick the one that's going to be the least amount of work. Once again, you could do a similar check to what we did before. 5 times 2 minus 3 times -1 is going to be 10 minus -3. That's 10 plus 3, which is 13. And 2 plus 2 times -1 is 2 plus -2, which is in fact 0. Okay, so those are two good examples. Let's take a look at our special cases real quick. So, since we've kind of already ruined the surprise by saying that these are special cases, we would want to see what's going to happen here. So what I want you to do is pause the video and try to solve each of these, solve them both right now, and when you come to a point that seems a little different, you can stop. So pause the video, do the work, and then come back. All right, let's see how you did on both of these. Okay, so let's see what happened here. When I did substitution on the left, I ended up getting my x's to cancel out, and I got 24 equals 7. Well, first of all, that's not true. That's just completely false. And because it's false, we're going to draw the conclusion that there's no way to make this work, which means that we actually must have parallel lines, which means we have no solution. So we know that this is the possibility when we saw it from graphing, but if you end up with a statement that's false, it means the lines are actually parallel, they do not intersect, so we have no solution. All right, and then the other one, my variables once again cancel out, and I end up getting -6 equals -6. Maybe you added 6 to each side and got 0 equals 0. Either way, that is true. And because it's true, it's actually true regardless of what x and y are, kind of. And so this is our other special case, which has infinitely many solutions because they're actually the same line. And so that's our other special case here. If the equations get the variables to cancel out and you end up having a true statement, we have the same line, therefore we have infinitely many solutions. All right, and that's a big summary of substitution. Hope this all makes sense.